Hi, my name is Soumya. IC engine develops power once in every 4 strokes. Combustion is required to get power. For combustion, we require fuel, oxygen, and fire. Fuel contains hydrogen and carbon, called hydrocarbons. Air contains oxygen, fire. During combustion, chemical reaction takes place and produces byproducts as results called emissions. If the combustion is complete, the emissions from the engine are harmless. But if the combustion is incomplete, then the emissions from the engine is harmful to the human and the incomplete combustion to be cured. To convert the harmful emissions into harmless, many emission control systems are used in the automobile. Now we are going to learn one of the emission control system component called Positive Crankcase Ventilation, PCV. This system is designed to remove harmful gases from the engine crankcase, preventing them from entering the atmosphere.
At the end of this demonstration, you will be able to know the working of positive crankcase ventilation, know how to check positive crankcase ventilation. Tools required: Trainees Toolkit. Equipment required: a petrol vehicle in running condition. Materials required: positive crankcase ventilation valve, soft cloth. The complete combustion of fuel creates carbon dioxide, CO2, water vapor, nitrogen, inert gases. These are non-pollutant emissions. But improper air-fuel ratio and incomplete combustion, pollutant emissions will come. The reduction in automotive emission provides cleaner air to breathe, reduces health hazards such as respiratory diseases. Automotive emissions mainly pollute air. Being a technician, you should understand the types of vehicle pollutants, allowable standards for these pollutants, how each automotive emission control device operates to reduce harmful emissions. The main automated polluted emissions are unburned HC, hydrocarbon, CO, carbon monoxide, NOx, nitrogen oxide, particulate matter, concerned with diesel vehicles. The non-pollutant emissions are CO2, carbon dioxide, O2, oxygen. The three sources of emissions on a vehicle are exhaust emissions from the tailpipe, evaporative emissions from the fuel tank, crankcase emissions from blow by gas. Now, we are going to see what is crankcase emissions. Hydrocarbons are the crankcase emissions. The crankcase emissions are mainly in petrol vehicles. Hydrocarbons, HC. HC emissions are caused by unburned air-fuel mixture in the combustion chamber. At the end of each combustion event, some unburned air-fuel mixture is on the cylinder wall surfaces when the flame front is quenched near the surface. This action results HC emissions. The air-fuel ratio becomes richer during deceleration and this decreases HC emissions. HC emissions mainly from the crankcase and the fuel tank. Crankcase emissions. Crankcase emissions are caused by combustion blow bypassed the piston rings into the crankcase. This condition causes HC emissions to enter and accumulate in the crankcase. Emission standards. As per BS4 standard, the permissible HC in petrol vehicles is 0.1 gram per kilometer and permissible HC in diesel vehicles is 0.3 gram per kilometer. BS4 petrol CO gram per kilometer 1.0, petrol HC NOx gram per kilometer 0.1, 0.08. Petrol PM gram per kilometer not applicable. Diesel CO gram per kilometer 0.5. Diesel HC NOx gram per kilometer 0.3, 0.25. Diesel PM gram per kilometer 0.025. As per BS 6 standard, permissible HC in petrol vehicles is 0 and permissible HC in diesel vehicles is 170 mg per kilometer. BSVI petrol CO milligram per kilometer 1000. Petrol THC plus NOx milligram per kilometer. Petrol THC milligram per kilometer 100. Petrol NMHC milligram per kilometer 68. Petrol NOx milligram per kilometer 60. Petrol PM milligram per kilometer. Petrol PN X per kilometer. Diesel CO mg per kilometer 500. Diesel THC plus NOx milligram per kilometer 170. Diesel THC milligram per kilometer. Diesel NMHC milligram per kilometer. Diesel NOx milligram per kilometer 80. Diesel PM milligram per kilometer 5.0, 4.5. Diesel PN X per kilometer 6.9 into 10 inches. THC tailpipe hydrocarbon. NMHC non-methane hydrocarbon. PM particulate matter. PN particulate number. Now we are going to learn how positive crankcase ventilation controls HC emissions. First of all, we should know what is blow-by gases in the engine. In reciprocating internal combustion engines, the gas that leaks at the piston, rings, and liner system is usually called blow-by. The blow-by is a complex mixture of air, burned and unburnt gases, and oil mist. In order to avoid external pollution, the blow-by is recycled in the air intake system. This is called closed crankcase ventilation. The crankcase ventilation is of two types: positive or closed crankcase ventilation, open crankcase ventilation. Positive crankcase ventilation redirects the blow-by gases, which is in the crankcase, to the engine intake manifold and reuse it again. Open crankcase ventilation allows the blow-by gases in the crankcase to the atmosphere directly. Positive crankcase ventilation. Positive crankcase ventilation removes blow-by gases from the crankcase which contains HC. Then, the removed blow-by gases from the crankcase is redirected into the inlet manifold and allows fresh air to circulate in the crankcase. This is happening with the use of a PCV valve. A hose is connected from the PCV valve to intake manifold. PCV valve. PCV unit has tapered spring-loaded valve. Valve closes the unit when inlet manifold vacuum pulls. Spring tension pushes the valve open. Working of PCV system. PCV system pulls clean air from air cleaner into the engine, removes crankcase gases from the engine and directs them into the intake manifold. This action prevents crankcase gases containing HCs from escaping into the atmosphere. When the engine is running idling, the blow-by gases will be less and the manifold vacuum is high. At this idling, the PCV valve towards the closed position. So, reduced PCV valve opening is adequate. During wide open throttle, the blow-by gases will be more and the manifold vacuum is low. The PCV valve toward the open position due to spring force. So, more blow-by gases to escape to the intake manifold. Suppose if engine backfires into the intake manifold, the steel mesh or filter prevents any flame entering through the breather hose. The PCV valve seats against its seat, that is, it closes and prevents any flame entering into the engine. Locate the PCV valve in the engine. It is normally fitted in the valve door or some manufacturers say rocker arm cover. Loosen the clamp from the PCV valve hose. Remove the PCV valve by hand. Disconnect the hose from the PCV valve. PCV system maintenance. Check the clean air hose. Inspect the PCV valve hose for cracks, splits, deterioration, and internal restriction. Inspect the PCV air filter for oil contamination. Replace the filters if dirty. Remove the PCV valve and shake it beside your ear. Should rattle sound be heard during this action, be sure the PCV valve snugly fitted into the rocker arm cover grommet. Inspect the PCV valve for sludge deposits and replace the valve if necessary. Oil contamination in PCV valve. Check PCV valve. Ensure PCV valve is fitted with a grommet properly. Damaged PCV hose. PCV system diagnosis. Disconnect PCV valve from rocker arm cover grommet. Start the engine. Allow the engine to idle. Here, a hissing noise is from PCV valve. Vacuum should be felt when your finger is placed over the end of the PCV valve. If there is a little or no vacuum at the PCV valve, check the valve and hose for plugged condition.
Till now, we have learned the working of positive crankcase ventilation, checking maintenance and diagnosis of positive crankcase ventilation valve. PCV is emission control system device which helps to reduce HC emissions. Do this exercise with the help of your instructor.